Hello everyone and welcome back. In this video we will be implementing a tag extraction system, which is a system that takes in a publication as an input and automatically generates tags for you. We will be doing this using LangGraph. We will create multiple nodes. Each one of them is going to contain its own extraction logic. So we will have three different methods of doing the extraction. We will run all of them in parallel, and at the end we will gather the results from all of these nodes. We will give it to a single node in order to decide the final selection. So let's see how we can do that. So let's first go through the functions that we used in order to implement this. So remember, this is the graph that we will be implementing. Each of these nodes is a different extraction logic. For example, the gazetteer extraction is just a keyword matching. So if you look at the configuration here, we have a gazetteer entities YAML file, which contains some predefined things. For example, variational autoencoder is a type of machine learning model. MNIST is a very famous data set. Anomaly detection is a task, and so on. So these are predefined things, and basically the gazetteer method is if you find any of these things in the text, then you should be marking it as whatever entity it is. So it's just a list of predefined things. So yeah, that's the first node right here. The second one is LLM extraction, which is just passing in the publication to an LLM along with the entity types that you want to extract, and the LLM should do the extraction for you. And the last one is spaCy extraction, which is using a model from the spaCy package. It's a Roberta model, fine-tuned Roberta model, which is an encoder model. So yeah, these are three different methods. All of them are going to give you different entities, and at the end we will gather the results and select the final list of entities. So we will be going through the functions for each one of these nodes. So let's start by the logic for the LLM extraction. For this we have this function which extracts entities using an LLM. And it takes in as a parameter the text, which is the publication in our case, and the entity types that you are looking for. And these are the only two required parameters here. And what it does is it chunks the publication because it might be a very long publication. So you don't want to do this in a single LLM call. So it chunks the publication, and for each chunk, it calls the extract entities from chunk, which again takes in the chunk and the entity types. And basically it creates the prompt and sends it to the LLM to get the results. Now if you want to look at the prompt, we have it here in the prompt configuration. So I'm not going to go through all of that, however it's going to be available to you to check in the GitHub repository. But basically this is the instruction that given a text document and a list of keywords, identify all the relevant keywords in that publication. So yeah, this is a very straightforward function, which is something that we learned in module 1. This is on its own right now. This is just regular LLM prompting. And yeah, you give it the publication, gives you some tags. Next, we have the spaCy method, which is using a Roberta model from the spaCy library. So here we are loading the model, and we are passing in the text. And it's going to give you some entities. Now this is not an LLM, this is an encoder model, which means it has predefined types. So for example, it's going to give you names of people, it's going to give you dates, it's going to give you like products. So there are some predefined things that this model can do, but it's not a general purpose model like an LLM, but still it's a good way to do the extraction. So finally, we have the gazetteer method, which is just loading the configuration file that I showed before, which is this. And there is a regex pattern looking for any of these keywords. So if the publication contain any of these, this method's gonna report this keyword along with its type. So it's a very simple and very basic extraction logic. And these are the three nodes that we'll be using. Right now they are just functions. So let's take a look at how we can put them together into a LangGraph agent. So to create the graph, first we have to decide what the state will look like. So we will be using this state for the graph, which contains the text. In this case, it's going to be the publication, the entity types that we want the LLM to extract. So the LLM method is the only one that requires you to input some entity types, because gazetteer is predefined and spaCy is again a model that's fine-tuned for specific things, so it's not a general purpose model. So the LLM node is the only thing that requires the entity types as an input. And these three variables will hold the results from each of the nodes. So the LLM extraction will be here, spaCy will be here, gazetteer will be here. And we mentioned that at the end, after we obtain the results from here, we will be aggregating them in a final node. So the results of this aggregation, it's going to be the final entities right there. So this is the state that we will be using in order to create our graph. So now let's take a look at the nodes that we have in our graph. So the graph has 4 different nodes, 3 of them for extraction and 1 for aggregation. So here we have 4 different functions. So the first one is the LLM extraction node. Now if you look inside, it's going to call the extract entities LLM that we showed in the previous file, which takes in the publication and the entity types, and it's gonna give you a list of entities. And yeah, it's gonna be obvious when we run this at the end how the output's gonna look like. So this is basically a regular node with some LLM calls here. And the second one is the spaCy extraction node, again calling the spaCy extraction method similarly here. So all of them are the same. The only difference is which function are we calling, and we already discussed all of these functions. And finally, the aggregation node. So after all of the previous 3 nodes run, the aggregation node is going to run after all of them are done. And what's going to happen is, here's the prompt for this node. Extract the most important entities from the list of entities provided. So here we are giving it the 3 results that came back from the previous 3 nodes, and the job of this aggregation node is to pick the most important entities. And here we are enforcing the structure of the output to this pydantic class, which means at the end we are going to get a dictionary that has a key called entities, and inside of here you have a list of different entities where an entity has a name, type, and description. And we had already gone through this in module 1 when we talked about output parsing. So yeah, this is how you define the graph. Now if we look here, we are adding the nodes to the graph and adding the different edges, which is straightforward. So I'm not going to go through this because, again, this is covered in other lessons. So after running this, the graph is going to look like this. And now let's see what happens when we run this on an actual publication. Okay, so now in the main code, I'm loading example publication number 2, which is a relatively large publication, and we want to generate tags for this publication. So what's going to happen is, once I run this, this graph is going to start running. All of these nodes will have access to the publication. They will run in parallel because they are independent. And once they are all done, all the results will be passed here, and the aggregation logic starts. So let's see what happens when we run this. So as you can see, all of them started running. The gazetteer finished first because it's a very simple regex logic. There is no any deep learning models there. And yeah, it confirms that variational autoencoders exist in the publication, and they are a model, same as MNIST, anomaly detection, and PyTorch. And this is actually a publication about variational autoencoders. So I created the gazetteer based on the publication because I know these things exist and they would show up here. And the second thing is the spaCy extraction. So you can see it has a lot of things. However, this method is not as flexible as an LLM, again, because there are predefined categories. For example, organization. This is a misclassification, by the way. So MNIST is a dataset, it's not an organization. And yeah, it classifies variational autoencoder as a product when in fact it's a machine learning model, or it's a deep learning model. But again, this model, it has no category such as deep learning model. So it's not going to be as strong as a general purpose LLM, right? So yeah, it extracts some people names, which is good. These are mentioned in the references section. And yeah, finally the LLM extraction, which is going to be much better than the previous one. So yeah, variational autoencoder is an algorithm, MNIST is a dataset, and so on. So it extracts a lot of keywords. And after this is done, you can see the aggregation started. So the aggregation sees everything that happened before, and it chooses these 10 tags as the most important ones. So these are automatic. You can treat these as automatically generated tags. So you can extract these things and put them as tags for your publication. So we have looked at how we can implement a tag extraction system from a publication. And this is the graph that we used. And I wanted to bring up a very important point here, which is some of these nodes don't actually contain LLMs, like the gazetteer extraction. For example, this is a very defined logic. It's very deterministic. It's basically regex. And for the spaCy extraction, it does not contain an LLM inside it. It's just a deep learning model. So what I wanted to show here is that sometimes these nodes can contain deterministic code, or code that has nothing to do with LLMs, which is fine. So nothing prevents you from doing that. In fact, this is my personal preference. Whenever the problem you have can be solved without having to use an LLM, then you should not be using an LLM, because they always come with their own problems in debugging, extra costs, and so on. They are strong, but if the problem can be solved without them, then you should not be using them. So yeah, in this graph, only 2 nodes contain LLMs, which is the LLM extraction and the aggregation, and the other 2 is just deterministic code. So before we end this video, I would like to show you how it looks like if you were to trace this in LangSmith. So I actually set up LangSmith to trace everything that we ran together. So if we look here at the tag extraction project, you're going to see that there are a lot of rows as runnable sequences and a single row that is a LangGraph. So the LangGraph row is actually our main graph that we ran together, and it contains 4 different nodes, the LLM extraction, gazetteer, spaCy, and aggregation. And this is the LLM that we were using, the GPT-4o Mini. And you can see like the total number of tokens and the total cost that we used to do this extraction. So yeah, we used GPT-4o Mini, and we used like close to 5,000 tokens, and yeah, this is how much it's gonna cost you. And you can see that the aggregation node is the only node that directly contained an LLM. So if you look back here, you look at the nodes. So aggregation node is the only node that directly invokes an LLM. And that's why right here you can see it has some tokens. spaCy is a deep learning model, it's not an LLM, so no tokens here. Gazetteer, same thing. LLM extraction, it actually contains an LLM, but if you look here, it's not directly invoking an LLM inside the node itself. Instead, the LLM invocation happens inside this function here. And that's why this one is giving you 0 tokens. It's not being tracked here. However, there are a lot of rows that are runnable sequences, and you may ask why are there a lot of rows here? And the answer is, remember that this function actually performs chunking to the publication, and it calls the extract entities from chunk multiple times. So this method has been called multiple times, and in here you are creating the LLM and invoking on the prompt. And we've been doing this for multiple chunks, and that's why you have a lot of rows here. Each row is for a single chunk. And yeah, you can click on this and you get an estimate of how much tokens are being processed in this chunk. So yeah, that's it about tracing with LangSmith. So that's it for this video. I hope you found that useful. And personally, I think that the main key takeaway here, besides knowing how to create such systems, is knowing that the nodes in such agentic graphs sometimes can be deterministic. They don't have to always call LLMs. And the key takeaway number 2 is whenever you can solve the problem without an LLM, then please do not introduce an LLM. So that's it for this video, and I'll see you soon.